Hello everyone, my name is Thomson Lai, the Asia Digital Leader for AECOM. I'm very honored that my digital replica is here with you. Whatever I do, my replica will do the same in front of you. Today, I'm going to share with you my view about digital cities. Before going into detail, this is something about myself. I've been with the geospatial industry for more than 20 years. Currently, I'm leading the AECOM Digital for the Asia area, driving adoption of digital technology in the region. Every one of you should know, city infrastructure is critically important to mankind. Without the development of infrastructure, our life won't be as easy as now. However, since 2019, globally all nations have felt the sharp impact of the COVID-19 pandemic. Most have been hit hard due to lockdowns and movement restrictions, putting economic activities to almost a standstill at its peak. This has severely affected important sectors such as tourism, aviation, hospitality, manufacturing, and investment. It has also threatened livelihood and stressed social systems worldwide. Social inequality has worsened during this time. At stake is national stability, plus business and personal livelihoods. A year later, since the pandemic, governments all over the world are finding ways to better position the countries for post-COVID economic recovery and future resilience, where infrastructure development plays a key element. Infrastructure closes social inequality, and infrastructure development has multiplier effect of boosting and stimulating economic growth. A study of Business Roundtable, an association of CEOs leading companies in the US, found that with every single $1 of infrastructure investment returns roughly $3.7 in additional economic growth over 20 years. Zooming in a bit on APAC, across the different sectors of services, all of them essential utilities for economic and social growth, the gaps are even clearer. As you can see, among them, transport-related services have the largest shortfall. But as government, commercial corporations, and people work together, realize this infrastructure development progressively, our cities continue to evolve with new emerging stresses on the systems. This includes changing urban population composition, workforce and business needs, and growing climate and pandemic threats. Cost of execution and ability to realize value of investment are also big challenges that inhibit progress. The time is now to consider new parameters and planning scenarios, particularly digital innovations in our future infrastructure planning. As the gaps start to close with more projects being built, it is critical to look beyond the hard-built physical asset. One of the most important aspects that people have been putting tremendous effort is on how digital built asset can build alongside with physical built asset to maximize the investment on the city to benefit multiple stakeholders. To achieve this, building a digital city needs to be strategic with digital planning to drive the best outcomes. Traditionally, owners approach IT companies to procure IT infrastructure and application systems. Outcome could be successful, but sometimes, perhaps lacking of industry knowledge, the products delivered may not be able to meet the owners' and users' expectations. These days, digital asset is no longer a simple IT systems supported by hardware. It is a digital replica of our physical world. It has to be outcome-driven. It has to be customer-centric. It also has to be sustainable and resilient. There's actually no difference to physical asset. Building a digital city needs to have a forward thinking, including planning, design, implementation, operation, and together with industry knowledge in long run. Taking into consideration the owner's requirement, and don't forget the most important thing, the practical usage of the digital city. In the following slides, I'm going to share with you a few real cases from different locations of the world. See how the owners strategically plan and implement their digital infrastructure to support their day-to-day business. You'll see the 4 components on the screen that you are seeing now are always been taken into considerations. The first is about the city infrastructure. We always heard from people saying that we need to create a smart city. But why we are building a smart city? Lands Department of the Hong Kong SAR government has a clear vision on building their digital city foundation. Through our comprehensive digital studies, Lands Department decided to build a 3D digital city with information-rich spatial data. This city replica aims at facilitating the community to build more innovative and smart applications for the city, just like what we are using iPhone and Android, that there are ecosystem that people can build up on top of the platform with different applications. However, building up a highly dense 3D city like Hong Kong is no easy. Imagine we are using our traditional topographic survey method to capture data, even taking into consideration the latest 3D data capture technology. We will still need ages to create a complex 3D city like Singapore or Hong Kong. Therefore, Lands Department leverages the effort from public works projects. On one hand, 3D geospatial models are captured by latest technology. On the other hand, as built BIM models created through works project will be pulled in together in the same data repository. To combine 3D city models will be shared to serve both the needs from public works projects and 3D mapping systems. Lands Department actually moved one step forward. Together with the Civil Engineering and Development Department of Hong Kong Government, they pulled in BIM models and also 3D spatial data. Aligned with the governance being set up in this BIM harmonization project, data will be converted to open format, including IFC and CDGML, which support the common spatial data infrastructure initiative of the government, and to support the building up of the 3D spatial mapping system in the future, which will be open enough for application usage and everyone's use. The second one, zoom in a bit. We just talk about a digital city level, but zoom in a bit on a big mega size and mobile infrastructure things. It's a project in Malaysia. MRT Corporation in Malaysia, KL, actually plans to develop the second line, but now the project is actually in 2017, so the line is actually in commencement already. They developed the second line of the Klang Valley Mass Transit Railway System, which is a 52.2 km long with 36 stations. Similar to all the mega-sized infrastructure projects, they share the same challenges. They have a vast amount of data, including CAD drawings, geotechnical information, different design intent, storing in different systems. And these data are not easy to be stored and also very difficult to be retrieved. Therefore, the customers, the MRT corporations, decide and plan for at the very beginning of the project, during the prelim design stage, they have to set up an enterprise GIS platform to manage all the spatial and non-spatial data for the design and construction of the Line 2 projects. All the data, including CAD, GIS, and BIM data, are geospatially enabled and putting in the same web portals. People can make use of the centralized hub to retrieve all the information for decision making. A common data environment is also set up to store all the BIM data, to retrieve all the detailed design within the BIM models. It's not only about information sharing and management. The planning on the system is actually also for the construction stage. Together with all the information managed in the web portal, all the information in construction site, together with the design BIM models, the drone data that we capture every single week, and also the geospatial data. All this data will be mashed up together to help the client to monitor the progress of the construction every single month. You can see from the screen, all this data are mashed up to show the progress of the data, the progress of the project from time to time. We just talk about the strategy on a mega-sized railway project. But how about the existing building infrastructure? I'm going to talk about a digital twin created by the owner of a pre-war building. URA, Urban Renewal Authority of Hong Kong, has the vision to transform the building such as an ancient building into a smart building. As you all know, design and construction stage normally lasts for 5 to 10 years at most. But O&M stage, the operation and maintenance stage, is even longer and hard to sustain. It can be up to 30 to 40 years to be used. Defining the digital strategy is the key for us to better understand and what is required to develop a smart design and maintain the building with optimal efficiency. URA apply the digital technology in the entire project life cycle, not only for project management, also include design and construction. But one of the most important part is about the facility management, which is the operation stage. BIM and also BIM and other digital technology is also applied in this regards. But is it that easy to create a BIM-enabled facility management system, the digital twin? No. At the very beginning of the project, we work aligned with the owner that we create the governance and standards for the designer and contractor to create the BIM model alongside with all the necessary information, which may be include the design intent and the construction details, which will be transferred through the industrial standard, COBE standard, to the facility management system, which is IBM Maximo in this case. And the outcome, the final product of the process is actually a facility management system, which is a digital twin of the pre-war building. The users of this system is not the owner themselves, not ourselves, but the property manager. The property manager makes use of this system day to day, managing their works order, supervising the system of the buildings, checking about the energy efficiency. Anything is going wrong, that they have to go check and fix it. So this is a system that you already create for the property management, but also for smarter building, which we can operate and maintain it in a better way. Building a digital city for efficiency, closely monitoring a mega-sized railway project, and operating a building in a smarter way are of course important. However, how to take balance the infrastructure development and uplifting the ESG standards is equally important for a city. And then a digital city covering environmental perspective is crucial. Accounting for environmental, social, and economic impacts is an increasing priority for many organizations, and understanding and measuring natural capital is key. The Natural Capital Laboratory, set up in 2019, is a unique project to do just this: a live environment for identifying, quantifying, and evaluating the impacts of rewilding. Located in the Scottish Highland for the next 5 years, actually it's 4 years now because they started last year, the NCL is restoring 100 acres of forest and reintroducing lost species. New digital tools and techniques, together with a digital twin for the natural environment, have been adopted to track and communicate the complex data at scale, showcase the changes on the site, and create solutions which help tackle two of the biggest challenges of our times, that is climate change and biodiversity loss. Ladies and gentlemen, and all the geospatial fellows attending virtually, we all see people talking about digital twin. But why don't we take a broader mindset when dealing with our future infrastructure and city? So digital cities, the twin of our physical world, are a powerful tool to create value while tackling global challenges. But how are we going to build up a digital city? To this end, our Asia Digital team will release a series of papers collecting best practices and lessons learned. The first paper will be featuring the strategy for creating a digital city from around the world. Please stay tuned to the launch date in April 2021. Thank you.